Question 12. ABCD and APQR are two similar quadrilaterals. So that is, this shape here is a smaller version of this shape here. Or that shape out there is a bigger version of the first one. Those are the similar shapes, which means every corresponding length, the likes of the ones I'm highlighting here in red, I highlight them because they've got numbers on both of them. We have these two sides here in green, and we also have these two sides here in pink. I'm going to do one on the inside. This is the 5 here, that length and that length. All of them correspond to one another and can be related in the following formula. The length of the smaller one times by a scale factor that we don't know as of yet will give us the length of the bigger one. So part A is find the length of DC. So this value here actually we're looking for. Before we can do that, we need to figure out what the scale factor was. Now, the same way that my eyes were drawn to these two sides in first in red, that's where we start. We have the bigger length, we have the smaller length, which means we can figure out what the scale factor is from that if we sub them in. So 6 times something, the scale factor equals 9. Divide both sides by 6, scale factor is 1.5. So that means that all of the bigger lengths, the bigger red, the bigger green, the bigger pink, are 1.5 times as big as the smaller ones. Now x is a smaller length. So 12 is 1.5 times as big as it. I could also write it like so. X is the length of the small. We've already figured out our scale factor is 1.5. And 12 is the length of the big one. If we rearrange this formula here, we're going to end up with x is 12 divided by 1.5. And that's going to give us 8 centimeters. Part B, find the length of AR. Well, AR is the longer equivalent if we compare it to 5. So we use this formula again. This time, 5 is the smaller length. Our scale factor is still 1.5 for the length. Multiply those together, and that gives us 7.5 centimeters for AR. Next part. The area of the quadrilateral ABCD is 32 centimeters squared. So that is the area of this is 32 centimeters squared. So that's the area of the small shape, the small similar shape. Calculate the area of the shaded region. So that's the dark gray bit there. Now in order to do that, we're going to have to figure out what the area of the big similar shape is and take the area of the small shape away from it. Now the formula here works for comparing lengths and scale factors. The formula that relates to area is when you have area small times scale factor squared, you get the area of the big. Because when you, for example, double the length in a shape, you would double the width as well, and therefore the area gets double. So it has this double squared effect if our scale factor was 2. So whenever you're comparing areas, it's always the length scale factor squared. Now, we know what the area of the small is, it's 32, and we know what our scale factor is, it's 1.5. So if we do 32 times 1.5 squared, we end up with our big area, which in this case is 72. After that, 72 is the area of the big shape. Then we want to take away the small shape, this one here, which was 32. And that will give us the area of our shaded region, which is 40. So 40 centimeters squared.